This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
Today on Know-How,
we're going to dig deep into our couch cushions, find our old remotes, and repurpose them.
Welcome to Know-How. It's a Twitch show where we build, bend, break, and apparently karate kick.
I thought you were going to kick. Only I kicked.
No, it's a Kamehameha. It's a Dragon Ball thing.
I don't have any idea what that means.
That's okay. I'm Father Robert Palace here.
I am Megan Maroney.
And for the next couple of minutes, we are going to open up the memory vault that is your brain and pour in a bunch of bits of knowledge. It's kind of what we do here on the show.
Are we going to sew it back up afterwards?
No, I like the messy look.
Okay.
Industrial's where it's at. No, I don't do the whole clean and clear. It's like I let someone else fix it up. I just want to make it work.
Okay.
Yeah.
I'll clean up. I will sew. I took sewing in high school. I can sew up your brain after we're done.
Actually, you know who one of the best seamstresses I know is?
For heads?
I guess tailor. It's Patrick Delahanty. He's really good at it.
Okay, well, he will sew up your head after you're done.
Yeah. Well, that's always been a problem for me because like needle and thread, it means it goes through my finger at some point. I'm not good at it at all. Yeah. But we're not here to talk about clothes or sewing. We're here to take these things and turn them into something useful for you. Now, Megan, you've been around long enough to have a collection of remote controls, yes?
I do. You always need more than one.
It's kind of strange, especially since everyone's moved to the sort of the universal remote that comes with, say, your cable box that's supposed to control the tuner and the TV, maybe a stereo system. You still somehow end up with a multiplication of remotes. I went to my parents' home in Las Vegas not too long ago, and they had no fewer than 12 remotes, and they had no idea what any of them did. But they were afraid to throw them away because they figured if we throw them away, that's when we're going to need it.
Right. Also, if you throw them away, then it'll end up somewhere and someone else will have it and be able to control your television.
Well, yeah, someone in China starts pushing buttons,
yeah,
and next thing you know, you're watching the international channel.
I don't think that's how it works.
That's not actually how it works. But what we are going to do in this episode is we're going to show you how this technology works. It is so ubiquitous, it's everywhere, and then we're going to show you how to repurpose it. If you've ever wanted to build your own custom remote control, or perhaps you've wanted to IR control some devices around your house, this is the episode to watch. But first, Megan, here's a little thing about remote controls, of these types of remote controls. They use infrared. These are infrared LEDs in the back here. Actually, I'm going to go to the side shot so you can see. And what this allows me to do, if you go to the side shot there, Burke, there you go. What this allows me to do is it allows me to send a code using that little IR LED. Oh, actually, you don't have to do that. There you go. So, nope. Turn the lights back on, Burke. There you go. So what's happening right now, that little flash that you're seeing, that's actually the remote pulsing the LED. And then the receiver is going to take the sequence that just got pulsed, turn it into a code. That code is going to be interpreted by whatever operating system that IR device is using, normally an embedded system, and then it's going to do something based on what code it received. Super simple technology. Now, as you know, IR is not the most accurate of technologies. Have you ever done sort of like this? Mm-hmm. You're trying to find that perfect angle that just gets the device that you want. Well, there's a reason for that. It is a directional technology, and the sensor actually has to see the light, which sometimes you can get from bounces off walls and windows, but more or less it's a line of sight technology, and it's not guaranteed. This is one of the things that people really hate about IR control, which is have you ever had to press a button more than one time to make it work? Mm-hmm. Well, it means that there's no guarantee that just because I sent the code that the device received it and did something. right? And it would be nice if I could control something and be able to push a button, and then it would respond to me and say, yes, I've received that button push, and I know that the command has gone through. In fact, you've got a remote that actually does that.
Yes, well, this is the Apple TV remote that doesn't work with the IR, right?
It does not.
So, and even though we're so trained that I still do this when I'm trying to control my Apple TV and, you know, aim it, but really, I could point it at my face. I could point it at my brain. I could point it at my liver if I wanted to, and then I could still change the channels.
Right, and so that is mostly a Bluetooth remote, and which is not going to work with the IR project. But let me show you what it actually does look like. So I've got a little demonstration here. This is something that I've assembled. It's a little little something, something. I'll explain a bit more about what this actually does. Burke, if you go to the overhead, this device is actually an Arduino combined with an IR sensor and an IR emitter. So it's an LED. This is a self-contained unit that I just sort of use as my playground. This is what I mess around with when I want to play with IR commands. But I'm going to show you what these codes actually look like. Burke, if you go ahead and go to my computer, I've got SketchUp, which is the Arduino interface. Okay, so I've got my screen here, and what we're going to do is we're actually going to show you what the IR codes look like. I've got my serial monitor, which is, I've already pre-programmed this little module so that it can show me exactly what's going in. And go ahead and stay on that screen, Burke. So I've got my remote control, and I'm going to start doing this. So as you can see, every time I push the button, it's going to give me a different code. So let me change the button I'm pushing. So that first one was volume up, this one is volume down. Now you can kind of see how a TV works, because when it receives that code, 40BE30CF, it means volume up. This one, 40BE9867, means volume down.
So do those letters actually stand for something, or is it just code? It's
arbitrary. So they can make it pulse any code that they want as long as they program the receiver to do something when it receives that code.
Got it.
So it's like saying, okay, this is what I'm receiving, this is what I'm receiving, now what should I do with it? And there's another part of their code that says, if you receive this code, do this. If you receive that code, do this. If you receive this other code, do this. And that's why I can have one remote control that does all these different functions, because every single one of these buttons sends a different code. Does that make sense?
That makes sense. It also makes sense why there aren't so many buttons on the Apple TV remote, because it doesn't need all that.
It doesn't. Yeah, it's a different kind of device, and you know, this is really sort of, this was a miracle back in the 90s when people had remote controls so they didn't have to get up and hit the TV. But
I remember.
I remember that exactly. But it also means that it can be a little bit inexacting. In fact, Burke, if you go back to my computer screen, I'm going to show you something. Most remotes will do this thing where the first time they receive a command, they'll give you the, actually, let's press the number 8. They'll give you that, but if you hold it, notice how it starts just doing FFFFFFFFF. That's the, it doesn't have to be FFFFFF, but there's always some sort of code in every protocol that says just repeat the last thing I sent you.
Got it.
Which is kind of silly, yeah. Now we need something to be able to decipher all of these codes that are coming out of the remote control, have the Arduino read it, and then do something useful with it. Now luckily, some very smart people have already written up the libraries that we're going to need to be able to manipulate this data. Otherwise, I'd have to write it from scratch. Because remember, it's not just receiving a bunch of light pulses, it's also rejecting anything that isn't a proper code. That's why we're using this. Burke, if you go to the side view here, this is the side view. This is an IR receiver. Now, what this allows me to do is there's actually a tiny little integrated circuit in here, and it measures out the pulse so that my Arduino doesn't have to. In other words, it's only sending proper codes to my Arduino, not all the noise. Because if I was just hooking up a photodiode to an Arduino and saying, tell me everything that's coming in IR, it would be a garbled mess because there are so many different IR sources. In fact, these lamps that we have up here, they're also emitting IR. This little part allows me to sort of filter all the garbage out.
And where would you get something like that little part?
I'm glad you asked, Burke. If you go to the link there, we have, it's an 1838HS. It is a part that you can buy on pretty much any part store. This one coming to us from Amazon, it's going to cost about $6 for a pack of 5 of these along with the IR emitters, which I would recommend. I mean, it's not the cheapest, but this will get to you really quickly, and these things are guaranteed to work. So this is not an expensive project. Combine this with an Arduino Nano, which we already know is going to be about $3, and you've got yourself a very powerful little workbench for you to play with IR codes.
And could you get those little pieces out of some old thing, or would you really recommend buying them on Amazon? They're not like stuck somewhere in an old TV or something that you want to
I mean, they're so inexpensive. You know, why go through the trouble of trying to pull them out from another device? And I mean, Amazon sells them 5 for $6, 5 pairs for $6, but I've bought them in bulk. I bought 100 of them for like $10. So yeah, if you're going to be doing a lot of IR projects, just buy in bulk and it'll be a lot cheaper. Yeah, as Burke is saying, these are also they're kind of heat sensitive, so if you try to remove it, you're probably going to damage it. That's
so
not cool.
They break easy.
They do kind of break it easy. Now, if you go to the overhead, Burke, and then bring up the diagram that we've got in the TriCaster, it's got the pinouts. This is really the only knowledge that you need to make this project work properly, because there's 3 pins. There's out, that's where my signal is going to go out. So that's the data that's actually going from this little part to my Arduino. Ground, which is just the ground wire, and VCC, which is 5 volts. So if you give this thing 3 to 7 volts, it's going to work just fine, and it will start outputting codes to the out pin, which is what I want. Yeah?
Got it.
Okay, so that's what we're going to be doing. We're going to be creating a device that's going to take the data coming from the out pin. It's going to use a library that someone else wrote to convert that into a code, and then ultimately I'm going to take the codes that are being received and I'm going to do something with it. Does that make sense? Because we're going to totally confuse people as we start to get in
No,
here.
trust me, I'm the one that's following along like you at home and doing my best. I will ask questions when I have them.
Fantastic. Okay, so Burke, if you go ahead and go back to my computer, please, and stay there. This is something we have to do first, is we have to make sure that the library that we're going to be using is in here. And in this particular case, the library is called irremote.h. Now, I already have it installed, but for the people who are doing this for the first time, the way that this works is you want to go to Sketch, Include Library, Manage Libraries, and then this little window will pop up, and if you just type in IR Remote, you're going to get a list of all the libraries. Now, this one's already installed, but I would just click this and click Install if I didn't have it installed. Now I have the library that somebody else wrote. Makes it a lot easier for me to do my job. Okay, now let's go ahead and code. Now, Megan, this here, what you're seeing here, this is called Sketch. This is the IDE, the Integrated Developer Environment for the Arduino. So I've got this little piece right here. They go to the overhead. I've got this little piece right here, and what I am doing now is I am using an environment that was designed to be able to push code to this thing. So I'm going to give this instructions on what I wanted to do based on what I write inside my IDE.
Got it.
So this is whenever someone says they're programming in Arduino, this is what they're doing. All right, so here's what we're going to do. If you go back to my screen, this is the typical startup that you get. Anytime I turn on my Arduino Sketch, it's got setup and loop. I'm going to go ahead and delete that for now because I've got my own code. The first thing I'm going to do is that library that I just imported, stay on my screen, that library that I just imported, I'm going to go ahead and include it. So I'm going to put a little hash mark, include, which tells the environment, okay, this following file, make it available for all the programming that's going to go on here. I'm going to say, I want to include irremote.h. Okay, and what that does, what I've done with that, even though you can't see the code, that has now taken somebody else's work and turned it into something that I can manipulate and I can use. Now, I also want to do this. I want to tell the environment where is the pin, because I remember I have one pin coming out that's going to give me all the data. Where am I going to connect that on my Arduino? And in fact, if you go to the overhead, Burke, these pins, these are all numbered. If you take a look at these, Megan, so I can choose any of these. What I'm going to do is I'm going to choose pin 2. So I'm going to have to connect it to pin 2, which is right there, for this Arduino to actually read it. If you,
so are the numbers on there, or you just have to?
They're really small. They're still screen, but they're actually on there. Yes, sorry about that. Yeah, they're a little teeny tiny.
But yeah, I can still see them even at my advanced age.
Right, and what we've always done is we've always done it up here, because if we ever make any changes in the future, we don't want to have to go hunting through the code to find where we assign the pin. This way, if I open this up in a year or 2 years, whatever, I'll see this line, this define IR underscore pin 2, and I'll realize, oh, okay, I've told it to connect the IR pin to pin number 2. Okay. All right. Next, I need to do this. I have to turn on the receiver, and this is a command from that library, from the iRemote library. It's called IRRECV IR pin. So what I've just told it, I've said, call the library IR receiver, use the function IR receive with pin 2, because that's what I said above, to tell it this is where the receiver it is, please turn it on. Okay? Next step, I need to do this, decode results IR code. And this is another bit of that library that I included at the beginning that's going to take the code and turn it into something that's intelligible. Otherwise, it would just be a bunch of zeros and ones on the screen. Okay. All right, next up. Now, this is where we start to get normal. Void setup. Every program that you ever write in Arduino is always going to have a void setup, and it's going to have void loop. Oh, voidy. Void loop. These are the two essentials because what they allow me to do is they allow me to set up the parameters that the Arduino is going to work under as long as it's on. And then loop is just the part of the program that just keeps happening again and again and again. So whatever I write in there, this Arduino will attempt to keep doing it over and over and over until I turn it off. Okay, super simple way to program. Now, let's go ahead and add the variables for my setup. I need to put serial begin. This turns on the serial port on the Arduino so that I can receive data back on my computer. Then I need this, recv.enable IR in. There we go. Now, Megan, this is kind of cool. Notice how some of these words are turning different colors? Mm-hmm. That's because the environment, the Arduino Sketch environment, knows that those are keywords. If you go back to that screen, please, Burke. It knows that those are keywords, and what it will do is it will change them to different colors so that I know that I'm calling on a keyword. It's just sort of a nice, easy way to make sure that I understand what I'm asking the environment to do. Okay, so I've got this. Now let's go ahead and do the loop. If I run the program right now, it will turn on the receiver, it will wait for codes, but it will not actually do anything for me. I have to tell it what I want it to do with the codes that it will be receiving. So let's go ahead and do that with this. We're going to put if, so this is an if statement. In other words, this will only run if what I put in these parentheses, if you go back, if just stay on this until I tell you to switch off. If, it will only run if what's in the parentheses is true. If it's not true, it will not run at all. Okay, so if irrecv.decode and, where is that and IR code. So what this means is if when I run the decode function, there is a code waiting for me, then run whatever's in the if statement. If there is no code waiting for me, in other words, if it hasn't received anything, then just ignore. This is about as simple as I can get because it means that it's only going to do something if it has something to do. Does that part make sense? Because otherwise it would be sitting there forever and just going, is that a code? Should I interpret this? And this way it just says, no, just wait until that little device, the receiver, has actually sent you a code. Otherwise, just keep waiting, just keep waiting, just keep waiting.
Computers are dumb. They need us to tell us.
They need us to tell them exactly what they're going to do, and that's what we're doing. All right, so if that's true, so if there is a code waiting, what these two brackets do, it means run what's in between these brackets, but only run it if there's a code waiting for me. So if there's a code waiting for me, what I want is serial.println IR code value hex, because it's going to be a hex value.
So how do you know all the abbreviations? Like you didn't write line, you wrote LN. Is that just something that you learn along the way?
Yeah, I mean, I have not memorized all these by far. I actually have a reference cheat sheet that's right next to me, and I'll just look over really quickly. But I mean, I know that I'm going to be dealing with serial. So there's a couple of different ways to do this. There's serial print, which just puts it on the screen. Serial print line means put it on the screen and then move down one line. And then there's also print tab, so it tabs over. So you just find the code that you need. So it's going to print, if there is a code waiting for me, it's going to print to the serial port whatever that value is, which is going to be a hex format, and then it's going to move down to the next line. All right, so that, and then I need this, irrecv.resume. What I've just told it is, after you've printed that, go ahead and wait for the next code. Because if I don't do this, what will happen is the receiver will send one code and then it will just stop. This line, the IR receiver resume, says, okay, I'm done with you. Go ahead and wait for the next code to come in. All right. So if I've done this right, when I verify this, oh, hold on, there we go. Space before hex. When I verify this, yeah, the space is fine. This is actually, if you take the know-how bug off the screen, because I can't see this part. Okay, so it's done compiling. What that means is that the code works just fine. We're going to go ahead and upload this to our device. And our device is right there. It is an Arduino Nano. And let's go. All right, so we're uploading it now. And then we're going to open up the receiver window just to show you that the code actually does work. Now, Megan, one of the cool things about this is the fact that we all have infrared remote controls, and most of us have a couple of remote controls that don't do anything anymore. This can breathe new life into them. So again, this is the code that we just wrote, and when I push the buttons, all the different buttons are going to give me all the different codes.
So you are pushing the buttons on the remote. Mm-hmm. And you're doing that with the remote.
Right. If you go back to the overhead, Burke, so what we're doing is just this, and it's being received by that receiver, which is tied to my computer via this cable, and then my computer is converting the infrared pulses, which you should be able to see there, those infrared pulses into code. In fact, here, go crazy, Megan.
Okay, I can press any button.
Yeah, any button. So, well, do you want to point it?
Oh. I was doing the Apple TV remote thing. I was pointing it at the Apple TV.
Go back to my computer screen, Burke. And so, yeah, so what's happening is, and notice how if you hold the button down, see how it's doing that FFF code? That's the repeat code. It says, okay, the last thing that I sent you, just keep doing it.
Oh, you want me to, that's the repeat
Yeah,
code.
that's the repeat code. So if you hold it down long enough, it just starts sending the FFF code, which means the last code that was in memory, just keep repeating.
Okay, that makes sense, but I can't make each button do something different.
Oh, of course you can.
Oh,
yes, that's what we're going to do next. Okay, so right now, this is semi-useful.
Okay.
All it's done is it's allowed me to see what codes are coming out of my remote. Now, I could take this device, and I could go to all the remote controls I have in the house, and I could see what are the list of codes that are useful. Because in other words, if I have those codes, then maybe next week when we show the other part of transmitting, I could transmit from my little box. But right now, we just want to trigger something. We're going to trigger an action because we pushed a button on the remote.
Got it.
Let's go ahead and do that. So if you go ahead and go back to my screen, we're going to take the same program, but we are now going to improve it with a little bit of triggering action. So the first thing that we have to do is everything's going to stay the same. All of these variables, we're still connected to pin 2. We're still opening up the serial port. But we need to add a little something, something. And what I'm going to add is a function I wrote called IR control. And I don't want to have to retype the whole thing, so I'm just going to copy and paste it and then show you what it does. This is IR control. So what IR control does is it uses what's called a switch. Now, in Arduino, in C, a switch is a case statement. In other words, it only runs in case something is true. Right? And in this particular case, if you go here, case this. So 0x means if a hexadecimal value of 40BE728D occurs, then do everything between the case statement and the break statement.
Okay, so what's the difference between if and case? Like if then and a case.
Right, because so an if is you can embed ifs. You can say if this, then if this, then if this, but then you get this really kind of convoluted logic tree. Case is what you would use if you know there's going to be multiple values and you have to trigger multiple things. I can make an if statement work like a case, and I can make a case work like an if statement, but they're two different tools that are just different enough where it makes sense to use case if I've got a long list of commands, and if only if I've got a short list.
So make the difference between a bread knife and a steak knife, perhaps.
Yeah, they both cut, but you wouldn't want to use a bread knife on your steak, and using a steak knife on your bread, well, that's just a faux pas. People think less of you, right, Megan?
Well, I mean, but you can use one if you have to.
If you have to, if you have to, okay. But let's go back to this. So I've got 3 case statements here. Case is this one, so this code, and this code. These are 3 different codes, 3 different values on my remote. And in particular case, all I'm going to do is I'm going to say print left, or if it's the middle one, print OK, and if it's the bottom one, print right. So that's what we should see. That's what's going to happen when I go ahead and activate this. Now, I do also have to change my main loop because I have to call that function. So if you look at the loop, it's going to do the same thing that we did in the first example. It's going to say, if and only if I've received a code, then do the following. And the following is print the code, then go ahead and call the function that does something. So that's all we've changed. We've added this part right here, IR control, and we've written a function called IR control. So let's go ahead and send this to my device. We're sending it to COM4, and please program. Thank you. Now, Megan, this is the first step in allowing me to do something useful with the remote control. Because if I can trigger something as simple as printing something on screen, it's just a hair's width away from me doing something like using my remote control to, say, turn on a fan or turn on a faucet. All these things are know-how that we've shown people how to do, activated via an Arduino. I can do this. This is just another way to control. It's just another switch. And it's another button, but in this case, I have a remote with a lot of buttons. All right, so I'm done uploading. So let's go ahead and open up my serial console. And Megan, if you would, I'm going to give you this remote here. I've programmed, go to the overhead, Burke. I've programmed the codes for these 3 buttons. So for this button, and this button.
Okay.
So it'd be left, right, and OK, which is actually what it is on it. So if I've done my programming right, when you hit any of those buttons, a different thing should happen on that screen.
Okay.
Okay, so there we go. So point it at the receiver, and if you go to the screen, Burke, there you go. See? So that's, you're hitting OK, now you're hitting left, now you're hitting right, now you're hitting left, OK. See? So this is triggering. That only happens if the Arduino receives a very particular code, a code that I told it to receive. Now, if I wanted to change it, I could do this. Now, Burke, go ahead and go back to my screen. Let's say I wanted to, there we go. Let's say that's the number 5. So if I wanted the number 5 to trigger something, all I would do is I would copy that, go back to my code, and change it here. So now instead of the OK button triggering OK, the button for number 5 will trigger OK. And let's just prove that that's right. So I can take any value that's coming out of my remote and I can make it do anything I want. And uploading and done. OK, go back to my screen. Oh, I turn on the serial console. There we go. There we go. Even though that's not the OK button anymore, that's the 5 button. I've just reassigned it. Does that make sense? Mm-hmm. Right, so here's what we've done so far. We've shown them how to get a library that will let them interpret the R codes. We've shown them where they can buy these things, these receivers, and we've shown them how they can interpret the data that's coming into the receiver to do something unique when I hit that button. Okay, here's what we need to do now, though, before I go on to the next triggering exercise, because I do want to show them how to do something a little bit different. Would you be interested in seeing how this hardware actually works?
I would be interested in that.
Okay, so here's what we've got. We've got this little device here. I made this because I got bored, and yes, that is the seal of the Jesuits.
How'd you put that on there?
3D printing. It's, again, I get bored, I make things.
Mm-hmm.
But the reason why I made this is because I wanted a little playground whenever I'm doing IR projects, and that's what this does. Oh, I hope I can get this off.
What kind of screwdriver are you using there?
I don't know. This might be an iFixit screwdriver. They're currently a sponsor of the Twit TV network. Let's see if I can actually get this out.
Does it have a name?
This is one. No, this is just from the iFixit kit.
Oh.
And there we go. Not stripped. It's just the 3D model that I created. Yeah.
So you didn't do anything to the remote itself, right? So I could have used any of these remotes.
Right. No, yeah, any remote. All you have to do is that first step of capturing the codes. So you need to see what the codes look like, and then you can interpret what's happening. All right, so this is what's inside here. Super simple circuitry. So I've got an Arduino Nano. This is the heart of the device.
So that little square is the Arduino.
Well, this thing, this whole thing. The whole thing is Arduino
rectangle.
Nano. Right. This right here, this is where the receiver is. Right here, that's where the LED is. So that's my transmitter side, which I have not used yet, but we will maybe next week. So this super simple circuit allows me to receive any IR code and interpret it, and it will also allow me to send any IR code that I want, which we haven't used yet. But let's go ahead and show people how to do this from bare bones. So we're going to build this so people are not confused about how they actually make one of these things. Now, everyone, if you go to the overhead, there you go. Everyone knows what this is. This is an Arduino Nano. This is a little breadboard that I had with the receiver. Now, as we said at the beginning, I only need 3 pins for this. I need power, 5 volt, I need ground, which is black, and I need signal. This yellow line is the line that's actually going to be giving the data to the Arduino. These 2 are just power, right?
Why do you need 2 for power?
Well, because you need a ground line and you need a voltage line.
Okay.
Yeah, so anytime you've got power, DC power, you need 2 lines. All right, so here's what we're going to do. We're going to hook up, because I know you can't read it, I'm sorry, Megan. There's a 5 volt line here and there's a ground line there. Actually, here, go ahead and give me the Megan stamp of approval. Do you see GND, which is ground, and 5V, which is 5 volts?
You could also get like a little magnifying glass.
I probably should, yeah. So here's what we're going to do. We're going to go ahead and do this. Let me lock these together. And I'm going to hook up the 5 volt to the 5 volt line and the ground to the GND, to the ground line. And do you remember what pin I told it in the programming? What pin I told the data to go into? 2, right. So D2 is right there. D2 is right there, which means plug it in right there. So this is now active. This is one of the simplest circuits we've ever made on Know-How. All I had to do was give it power and then put the data line into D2. So technically, if I were to load this up with the software that we just created, I should be able to make it do the same thing as the finished product. Let's go ahead and try that. So let's hook this up. It's got power. I got to go over to my IDE and tell it where to find the Arduino, and let's go ahead and try to upload. It's going to compile the sketch, which means it's just checking through the code, making sure there's no errors before it, and now it's uploading, and as soon as that's done uploading, so if, Megan, if you would, grab the remote control, and go ahead and press the number 5. There you go. There's the OK code. So this was fresh. There was no code on this. This means the code works and our circuit works, right?
Yes, that's exciting.
Well, kind of exciting, but I mean, still, I'm kind of locked into my computer. I mean, this not so useful. I mean, okay, I see codes, but I don't think that's going to entertain us for more than a couple of
well, it's
minutes,
useful
maybe.
For learning.
It's useful for learning, but let's make it useful around the house. I've got one more little module here that I've created. What I want to do is I want to actually trigger something in the real world. Burke, if you go to the overhead there. Thank you. I want to trigger something in the real world. In this particular case, I have 2 LEDs. Now, the reason why I'm using LEDs is because it's easy, but also if I can trigger these LEDs with the remote control, I can trigger anything. I can trigger a relay that starts a massive piece of equipment. I could unlock doors that are electronically controlled. I can turn on and off an alarm system. This just shows you, if I can get this to work, it shows you that what we've done today is practical for anything beyond just practice. All right, so let's go ahead and do this. So we're going to tie this to the system like that. I love these, like little Legos for,
they are.
For geeks.
Did you 3D print those or you bought those?
No, these are all bought. My 3D printer is not good enough, Megan. All right, so I need, here we go. This is going to be my ground, so I'm hooking up to the same ground pin there. And then I've got 2 different colors. I think it's orange and yellow. Let me make sure. I kind of forgot. Okay, so that's the white one, and I think that one is the blue one. Okay, so I need these 2 colors. I need red and orange. What I'm going to do is I'm going to tie that into digital 3 and digital 4. Okay, so what I've just done is I've hooked up 2 LEDs. One is on digital pin 3 and one is on digital pin 4. So what I need to do is I need to program this so that if I push the buttons on this remote, it will trigger digital pin 3 and digital pin 4. So let's go ahead and do that. Okay. If you go back to my screen, Burke, let's just go ahead. This is a bit more complicated, and I don't want to write the whole thing out, so I'm just going to copy and paste it because I am a cheating dork.
Use the tools that you have.
I do. There we go. Okay, so this is the whole code. The top looks exactly the same. So this is still the same program that we dealt with in the last 2 examples. I've done this, pin mode 3 and pin mode 4. So what I did was I told the Arduino, digital pin 3 and digital pin 4, if you go back to that screen, are output. In other words, they're only going to be used to send out a signal. And what that means is if I send a signal to 3, it's going to light up one of these LEDs. If I send a signal to 4, it's going to light up the other one. Okay? Now here's my loop. my loop looks exactly the same. This is exactly the same as the last example. The only difference is what's happening in the function that I wrote called IR control. In this, I'm still using case statements, but notice how I've added this. This is the only part that's different about this function. Digital write 3 high, which means if this is triggered, if this code is received, it will write high, which is on, to digital pin 3. Down here, it says if this case happens, so this is the write button, digital pin 4 goes high. The middle button, the OK button, if I push that, both digital pin 3 and digital pin 4 will go low. So this is what it means. If I hit the left button, it will turn on one LED. If I hit the right button, it will turn on the other LED. If I hit the OK button, it turns off all the LEDs.
Got it. So it's kind of like when they go low, we go high?
Yeah, well, when it goes low, then I go off.
Okay.
That's, yeah, you know, it's a thing. It's a thing. So let's go ahead and upload this.
Okay, let's do it.
Let's, okay, COM4, good, and push it. And Megan, I'm going to give you, I have no idea if this is going to work because I haven't tested this wiring yet, but we're going to give it to you. So same thing, you're going to push left, right, and OK, and these should do different things. We're done uploading. So if this is working, these LEDs are going to light up and turn off based on what Megan pushes. So
okay.
Actually, it's over here.
Oh, okay.
Okay, so go, okay, go ahead.
Left.
There you go. Right.
Right.
And OK.
Okay.
There you go.
You did it.
So you can, any combination you want. So you are triggering something in the actual world. This is not just on a computer screen. This is not just in the serial console. This is something, and if I can trigger LEDs, this is a principle that we've taught to our know-how group. If I can trigger LEDs, I can trigger anything.
Anything?
Anything.
I was going to say this kind of reminds me a little bit of the snap circuits that my kids had when they were little, but now this has made it even more awesome.
Yeah, the snap circuits are just this. It's just an easier way to hook it up. This is using jumper wires and some breadboards, but it's the same idea. It's learning a little bit at a time. Because imagine what we've done in this episode. We started by learning, well, what is an IR signal? Then we learned about, okay, this is the device you need to read an IR signal. Then we learned about, okay, this is how you program that device. Then we learned how to assemble the device so that it could trigger LEDs. And then we did a final code example to actually trigger those LEDs.
So, and we use stuff that is really cheap and stuff we already have around. Because, you know, you might say like, well, obviously I could buy a remote for my lights, you know, and pay $40 for that, but this is way less than that. If
you buy all of these parts brand new, to make one of these devices, it's going to cost you about $3.50. I mean, it's incredibly inexpensive, and this, you know, this is one of these things where, again, yeah, it looks super simple. There's not much to this. But imagine what we just proved. We proved that you can take any remote you have around your house and use it to actually do things. I could turn lights on in my room. I could turn fans on. I could, you know, I could raise and lower the garage door. Now, Megan, I will say this, however. Remember one very, very super, super crazy important thing, and that is IR has no security whatsoever. So don't hook this to anything that's important. Does that make sense? Because anyone who has one of these circuits, they could be intercepting what IR signals that you're sending, and then they could just repeat it. In fact, that's what we're going to do next week. We're coming back to this, and we're going to activate the other part of the circuit, which is the transmitter. So right now, I can receive signals from an IR transmitter and then do something. Next week, we're actually going to use the IR transmitter to send signals out and, for example, make a TV be gone. Do you remember those?
Oh, yes, yeah.
So I could program my Arduino with every off code for every TV and then do something like walk into a Best Buy and just click a button and everything would shut off.
I don't think that's legal.
It's not, and I would not advocate it, but here in the Twitch studio, can you see all these TVs? Mm-hmm. Imagine, and they all use different remotes. Imagine if one button turned them all off and one button turned them all on. That's what we're going to be doing.
Yeah, or in my house would be nice too.
Yeah.
Turn one button, turn off or on. I have an overall question. The code that you talked about that someone else wrote, is that just like, is there someone that we would need to give credit to, or is it so many people have written it?
Yeah, no, it's I mean, the credit's already in there. So when you do the library, when you use the library, it actually shows you who wrote it. We all submit our code back. So everything I write, I push back. This is kind of the open source environment. This is, we want to share our code. In fact, some people took the code that I wrote for the LED clock and they turned it into something much better. I've adopted their code rather than mine because they're so much better at writing it. And you know, yeah, acknowledge it. Don't pretend like it's your own code. Like what you see here on this screen, that's my code. But the library that makes it possible, that was somebody else. And actually, you know, let's say exactly who that person is. We're gonna manage our library again and look for IR receive.
The library or the building blocks?
It was created by Sharif. So Sharif, thank you very much for your library. It is something that I could have written, but why write it if it's already written?
Right, exactly.
It doesn't make sense to use up your time for that.
Okay, and so Sketch was the programming tool for the Arduino.
Right, and this works on Windows, it works on Mac, it works on Linux. This is a project that anyone can do. In fact, I'm gathering together the tools so that will work on a Chromebook. So if someone has one of these, they'll be able to do these projects step by step by step. And as you do these projects and you keep building upon them, it expands the knowledge and it expands what you can do. This, again, simple project, but on know-how, we've already done things like triggering relays and servos. We can take that knowledge, apply it to this knowledge, and make something new. And really, that's what the maker movement's all about.
I'm excited. I want to go teach someone else how to do this.
Yeah, you know what I'm gonna do? I'm gonna give you a kit. You can take this, you can give it to your kids, have them go crazy with it.
They will go crazy with it.
I was gonna make one for Burke too, but Burke.
He'll Burke it.
He'll Burke it up. No, that's. Now, do you have any questions? So, if you were, I mean, the reason why I wanted you as the co-host for this is because you don't have a programming background. Is there anything about this that you think the normal out there would need to know or doesn't understand about what we've done here?
Well, I guess my other question was, can you use something else besides Sketch, or is Sketch the only, is that what you recommend?
Well, I mean, for Arduino,
it's the only
thing.
Okay.
But there are a lot, Arduino is not the only embedded processor. In fact, when I'm doing projects with IR, I prefer to use what's called an ESP. It's a much higher powered board. It's more expensive than a Nano, but it allows me to do other things. The problem with doing an Arduino is an Arduino doesn't handle multitasking. So it uses up most of its processing power to wait for those codes, wait for those codes, wait for those codes. And sometimes when you trigger other things, those things don't trigger immediately because it kind of skipped that part of the code, waiting for the next code. An ESP handles multi-threading much, much better. So I could do something like use this to run, very popular in our show, the WS2812. Those are the programmable LEDs. So you choose the right tool. And for every tool that you choose, there's a different developing environment, but the programming is mostly the same. Even if you switch languages, the logic behind the code doesn't change. The language may change, but you still have to do something like an if statement and a case statement, and you still have to know the logic tree of your program.
And so did we say where you would get the LEDs? Like, could you just repurpose them from something else?
Yeah, these are actually repurposed. I literally pulled these out of an old project that I had. But I mean, I got these from Banggood. I got a box of 1,000 of them for like $14. Those are not expensive. So yeah, there you go.
Okay.
Oh, Megan, next week, what I want to do is I want to take this to the next level. We are first going to show you how to transmit IR codes, and then we're going to do something a little special. If you've ever wanted to control your TV from, say, your phone rather than that clunky remote, what if I told you there was an easy way for you to program it so that you could send codes from your phone that could control everything in your house?
I would like that.
We're going to do that.
Okay.
All right. I promise.
Okay.
Now, folks, I know that this has been a lot of information. We've gone over some egghead stuff. We want to make it super, super simple for you to follow along. You don't have to copy the code off the screen. In fact, right now, already waiting in a Dropbox is the code for all of this. In fact, if any of you have trouble getting to it, it's you can find it at, dropbox.com/s. Oh no, I'm not going to repeat that on the stream. Never mind, that takes a long time. It's going to be in the show notes. Just go to the show notes. There's going to be a link for you to download the exact code that I just used, so you don't have to write anything new. And the show notes are found at twit.tv/KH. Now, not only will you be able to find our show notes, but you'll also be able to find a little drop-down menu for subscribing. And if you like know-how, if you want to see more of this kind of content, or if you just want to contact us, this is where you go. Subscribe so you can get know-how automatically downloaded into the device of your choice each and every single week. It's probably the best way to support know-how and the maker DIY spirit. Also, don't forget that we have a social group, Google+. If you go to Google+ and look for know-how, what you'll find is over 11,000 members, our Kitas, our know-it-alls, who can help you with projects, maybe give you ideas for new projects, answer questions, or maybe you can be the expert and pass your knowledge onto them. It's also a great place to post pictures and videos of your projects so we can show them off here. There's nothing that makes us happier than seeing you create something that just boggles our minds. So please, again, go to Google+ and look for know-how. Also, don't forget that you can find us on Twitter. It's a great place to follow the host of Twit TV. You can find me at twitter.com/PadreSJ. Megan, where do they find you?
I'm at Megan Maroney, and you can also find me on iOS Today every Tuesday at 9 a.m. Pacific.
Tuesday, that's right. And we've got a third member of our crew, Burke, today. You may notice that the switching is a little bit different. That's because Burke doesn't normally do the show, so we're very, very, very grateful for him stepping in. Burke, where do people find you?
An Elf3.
You can find Burke at ANELF3, which is Bill's Twitter address.
Email me at megan@twit.tv. I am basically Burke's secretary and his promotional manager. So if you want to hire him for events or anything like that, email megan@twit.tv and I'll take care of it.
See, that's the kind of love we got for each other. Yeah. And if you really want to reach Burke, email me and I'll go over to his desk and slap him on the back of his head.
I won't do that.
Yeah. Until next time, I'm Father Robert Balacer.
And I'm Megan Maroney.
And now that you know how,